All right, everybody out there, this is Coach Lowe coming to you with 7.7 normal distribution with the calculator using our technology. So it's going to be a lot faster, but you really have to watch what you're doing because there are different ways to look at it. And of course, different calculators will have different updates. And so you may be seeing a different look on your screen. So one thing that's going to be the same is for all these, you're going to go to the second button. You're going to go to VARs, so distributions. So you're going to go second. You're going to VARs. We want to get right up there with distributions. You're going to go to option number 2. So you can just punch in 2 right here. That's a normal CDF. That's what we want. And the way they're doing it right here, they want you to think about the lower boundary z-score, upper boundary z-score. So big thing if you're going with this look is you are going to need to find your z-scores, okay? And you need to think about what direction you're going. Are you going to the left? In which case your lower boundary is going to be way out there to the left. Or are you going to the right? In which case your upper boundary is going to be way out there to the right, or it can be anywhere in between. So you really need to think about the boundaries that you're looking for. With the technology that I have on my board, it's a little different. So my approach may be a little different than what you're going to see. I went ahead and went forward and did a couple versions of it that I've seen in the past. And it's going to look a little weird first, but I'm going to try to explain it, and hopefully this flows a little better. Okay. I'll come back to the technology part. I want you to know sort of what we've done before. So Danica Patrick, you got qualifying round, Indianapolis 500. She's going to have an average lap speed of 224. And hang on a second. Let's get this thing right. Okay, so she is going to have an average lap speed of 224, coming right through there. And you're going to have standard deviation of 0.7. So make sure you take a note. Those are the pertinents. And the distribution of her lap speeds was approximately normal. So again, you're looking for this telltale verbiage right here. Approximately normal, or distributed in normal fashion, or bell-shaped, or roughly symmetric, or any of that above. You know, you're talking about the bell-shaped curve, you're talking about the empirical rule, which is all those percents. And so as soon as you see that, you should be thinking, hey, I'm going to be messing with the bell-shaped curve. So by hand, what we'd be doing is the first thing is you'd be going for your z-scores. So you're going to take her number, which is 225. You're going to subtract the mean. You're going to divide it by the standard deviation. And I got the z-score being at 1.14. And so if you're thinking about this, just make sure you're thinking. That's going to be to the right, and you're going to be past one line. You should be. So you're going to be over here to the right, and I'm just going to put 1.14. Okay? So if you're looking ahead and you're trying to think about the percentages, think about the room. All that room that's going to be to the left. Okay? So definitely going to be well over 50%. So you're going to have a high number here. So once you get the z-score, what we do is we go to the table, and you're going to be going to 1.14 on the table. So you go like on the left side here, you go 1.1, then you're going to go across to, so see, that's a 0, 1, 2, 3, 4. So this would be the z-score 1.14. And as you see here, you're going to get the percentage 87.29. So according to that, color code this, according to that, that means there should be over here to the left 0.8729, okay? Or basically that's going to be 87.3%. So that's what you're saying right there. All that room to the left. And that's what they're looking for. So they want to know what proportion of her qualifying laps would you expect her speed to be less than 225. So that's all that to the left. Now, if they want to the right, you could just do a quick subtraction from either 1 if you're looking at the decimal, or you can just do a subtraction from 100% if you're looking at the percent. So just know, all right, be smart about this. Think about where they're going with it. They're going to give you hints as to which side they want. So here we want less than 225, so I'm going to the left side, which is right at the table. All right, so done. That's what we've been doing. Now here's technology. Two ways to look at this. I'm going to do this one first. First way is to go with more of a standardized approach. And when I say that, I mean your mean, which is this guy right here. They're using a different symbol, but this is your mean. Your mean is going to be right at 0. So think about this. If you're going with this approach, your mean is going to be right at 0. That's what that means. Standard deviation, so you're going by, of course, 3 lines to the right, and you're going to be doing 3 lines to the left. And what we'll do when we're going with this approach is our lower boundary, we're going to just try to get as much out of that small area down there as we can. So a lot of times we'll use -1 e to the 99, okay? And that's going to get as much of this territory out here as we can. So that's going to be our lower boundary. And the reason why we want the lower boundary going that way is because we want to go to the left. So we're going this way. So my lower boundary is going to be -1 E99. If I did want to go to the right, I'd probably use +1 E99 for the upper boundary, okay? So that's where this is going. So this is going to be -1 E to the 99 right there. And it's hard to read. My upper boundary is going to be whatever my z-score was. So my z-score is going to be right about that 1.14. So it's going to be over to the right. And so I'm going to be looking for, of course, all that territory that's going to be to the left. Okay. So if you plug this into the calculator, so lower boundary is -1 E99, upper boundary is the z-score that you got, 1.14. The mean is 0, standard deviation is 1, and you hit enter. You're going to come down here, and you may see the screen, and some of your calculators may actually start you with this screen. So if you're doing this, just make sure you understand this is definitely the lower boundary. This is going to be the upper boundary in this case. And of course, that's your mean, and that's your standard deviation. Okay. So you hit enter again, and you're going to see a nice answer right here. So if you're comparing, they definitely look pretty close. Okay, so that's using technology, going to standard deviations. Now you can, I've seen this happen before, you can just go with the regular numbers. And when I mean that, by the lower boundary, it's blacked out right here, but I think that was a 0 going by what we got down here later. That's a 0. Upper boundary is going to be her speed. So this is sort of how I'm looking at this one. So again, here we go. Her speed was 225, and that's going to be the upper boundary. Lower boundary is going to go all the way down to, and I use 0 because in my mind I'm thinking, well, you can't get any less than 0. So I'm going all the way down to 0 for my lower boundary, and I'm going to go ahead and put in the mean just the way it is, 224.2, standard deviation 0.7. I'm going to hit paste. I'm going to have this screen in the middle. You go hit enter again, and look at the answer. It should be remarkably close to these other ones. Now, it may be a little bit off, okay, but it's going to be very close, and it could be because, of course, on one we're using a very small -1 E99, so maybe we're squeezing out a little bit more information there, or it could just be how the decimals ended up. Maybe they got rounded, something got cut off, but these answers are very close. So in my class, I'd be happy with either one of them, okay? So it's taking me almost 9 minutes to go through the first line. Oh man, here we go. Next one. All right, so now you're going to find the percent above. So again, same situation. We got Danica Patrick. Average speed is 224.2. Still, standard deviation still going to be 0.7. And they want to know what proportion of her laps would you expect her speed to exceed. So we're going above, which means definitely on the bell-shaped curve, we want to go to the right. Okay? That's what you need to get out of that. We're going to the right. 223.6. So again, if you're doing it old school wise by hand, you would do 223.6, subtract the mean, divide by standard deviation. You're going to get a z-score of -0.86. You would go to the table, so -0.8, and you're going to go over 0, 1, 2, 3, 4, 5, 6, and that would be your answer, 0.1949. But you got to think about this. If you're over here, I kind kind of got it drawn out over here. If your z-score is right here at negative 0.86 and you go to the table, that's going to give you all this territory that's going to be to the left, right? But in this case, we don't want that. We want to be exceeding 223.6. We want to go to the right. So again, if you're going to the right, just do a quick subtraction. If you're using the decimal 0.1949, just subtract it from 1. If you're going with the percent, subtract it from 100. But 1 minus 0.1949 is going to bring you up to 0.8051. So that means there would be this much room going to the right. So it's going to be 0.8051, aka basically 80.5%. Okay. But we definitely want to be over here. We want to be on this side. So that's by hand. And if you were going with the technology, let's see here, both versions. Check this out. Notice the difference right here. I switched up the lower and uppers because I want to go to the right. So my lower boundary here is going to be the actual z-score that I got. So my lower boundary is going to be the negative 0.86. Upper boundary is going off the chart this way. So that's why I'm going to use the 1e to the 99. Okay, positive 1e99. So I'm going to squeeze as much of that room out as I can. And then the mean 0, standard deviation 1. And I crunch that out. And of course, look what I got. And it's very similar to what I got down here. Okay. And if you just want to go straight up fuel injection of your data into here, the 223.6, that was her speed. So that's going to be the lower boundary, and the upper boundary. You know what? It's hard to say what the upper boundary would be. So look what I did. I went back with the 1e to the 99. The mean is 224.2, standard deviation 0.7. If you crunch it, you're going to be right down here with, here you go again. It's a little different, slightly different, but very, very close. Okay, so definitely you got options about finding the answers to the bell-shaped curve problems. Tell you what, I'm at 12 minutes. I'm gonna go ahead and cut this one off. This will be part A, and I'll start the next one, part B, for the next 2 slides.